All right, I know that some of you are, I'm kind of repeating myself a bit here. Unit 4 is about naming things. We call it nomenclature, naming compounds in particular, and polarity. Polarity is about electronegativity. In Unit 3, the one we just finished, we learned to name some very simple binary ionic compounds. By the way, the word binary means there are two elements. It does not mean we have just two atoms. It means there are two elements. Okay? Binary means made of two elements. It doesn't mean made of two atoms. It means made of two elements. So H2O, water, has the element hydrogen and the element oxygen. So it's two elements. It's a binary compound. It has three atoms, two hydrogens and one oxygen. So the binary name means two elements, not two atoms. Okay? What we learned in the last unit was we find the charge on a metal, charge on a nonmetal, and when we put together a metal and a nonmetal, we know it's an ionic bond, an ionic compound. And in simple binary ionic compounds, you try to figure out how to put as many of the positively charged ions together with as many of the negatively charged ions as you need so that you get a zero charge overall. By putting together two aluminums, which have a 3+ charge, and three oxygens, which have a 2 negative charge, 3+, 2 negative. If I have three of these and two of these, it gives me a zero charge. And that's what we want. We want a compound to have no charge. We want it to be what we call neutral. And we also learned in Unit 3 that you name the metal just what it is on the periodic table. Name it by its element name. But the negatively charged monoatomic, that is single atom ion, monoatomic ion, you change the ending of the name to IDE. So we learned all this in Unit 1, okay, except for the fact that we have a new word, binary. Everything else was Unit 3, the last unit. All right, so what we're going through now are key things to look for when naming compounds or writing formulas. And the first thing is, are there just two elements or more? So what we did so far in Unit 3 was just two elements, aluminum in this case and oxygen. Okay? If there are more, there's a different naming system that comes into play. All right? Number 2, you want to know, are the elements all metals? Or are the elements all nonmetals? So are the elements all nonmetals, or is there a mixture of metals and nonmetals? If there's a mixture of metals and nonmetals, like with aluminum and oxide, or oxygen, you have one naming system. If all the elements are nonmetals, there's a different naming system. In fact, if the elements are all nonmetals and there are carbons that are bonded together, that's a different naming system from everything else. Okay, so it's important to know if you've got all nonmetals, if I've got more than one carbon and that carbon's bonded to another carbon, we got something entirely different. It's called an organic compound. We name it differently than we do other nonmetal compounds. Then another thing, number 3, are there any polyatomic ions? And then number 4, these are just key things to look for. It doesn't mean everything you have to look for, but they're some of the really, really, really important things to watch out for as you're trying to write formulas or write the names of formulas. So the last one is, if there are metals, do those metals have more than one potential oxidation number. Potential? No. Polyatomic? P-O-L-Y, atom, ic. I'm going to start with naming ionic compounds. Now there are lots of ways to classify different compounds. We're going to learn to name in this unit 4 classifications of compounds. Again, depends on how you're classifying things, but you could classify them into 4 categories. One classification is the ionic compound. Okay? Another classification is the covalent compound. That's where you're bonding nonmetals to nonmetals. But under that big classification of covalent compounds, we have that subclassification where we have those carbons bonded together, and that's a classification known as organic compounds. And then lastly, we're going to have a classification called acids and bases. But to name acids, we first have to know how to name ionic compounds. Okay? The bases get named like they're ionic compounds anyway, so you don't have to really worry about that. If you got a base, you name it like an ionic compound, but acids have a slightly different naming system, okay, or at least the non-organic acids. Organic acids fall under a different category. In a CP chemistry class, you won't be asked to name organic acids. Okay, so naming ionic compounds. There are 2 ways to recognize an ionic compound. Okay, one of those is the one we've already talked about. It's an ionic compound if metals are bonded to nonmetals. On the periodic table, there's a stair step on most periodic tables anyway, right here. All the metals are over here. Everything to the left is a metal. Everything up here to the upper right, that's a nonmetal. Okay, we're bonding a metal to a nonmetal. We have an ionic compound. Another way to recognize ionic compounds, or a type of ionic compound, is if the formula or name includes a polyatomic ion. Oh, it should be an ionic compound, right? Not and, but an. You're absolutely right. Okay. And so in Unit 3, we learned, generally speaking, what a polyatomic ion was. We learned specifically about 2 polyatomic ions. One was called ammonium, and the other one was called hydroxide. Okay, we learned about a lot of monoatomic ions. We learned about 2 polyatomic ions. And so, using that as our example, we said that a polyatomic ion is a group of atoms covalently bonded together but the overall structure has a charge. No, we're talking about naming ionic compounds now. The homework you did over the weekend was this stuff right here. Okay? Everything we did for homework on the weekend was pretty much covered by this right here.
So the homework was Unit 3?
It's Unit 3, but carrying over and connecting to Unit 4. But it was the homework had nothing new in it. Okay? All right. So let's look at an example here. Of a compound that has a polyatomic ion. So, let's see, sodium sulfate, yes, has a polyatomic ion. Now remember, monoatomic anions had what kind of ending on the name? "-ide", okay? So, this obviously isn't a monoatomic ion because it doesn't have an IDE ending. Okay? The ATE endings and the ITE endings signal to you you have a polyatomic ion. Actually a polyatomic anion. Okay? ATE endings and ITE endings signal to you that you have a polyatomic anion. A negatively charged particle made of atoms covalently bonded together. 8 endings and ite endings signal to you that you have a polyatomic anion. Monoatomic anions have an IDE ending, IDE. Polyatomic ions, for the most part, have either an ATE or an ITE ending. Okay? Sodium, we learned in the last unit, and we reviewed again today, is just the metal part. Okay? This is a metal. And so that's Na, polyatomic anion. Now we know then from the ATE ending that this is an anion. It's negatively charged. If it's negatively charged, if it's a polyatomic anion, we must have an ionic compound. That's what we set up here. Okay? So if it's a polyatomic compound and the sulfate is negatively charged, I'm looking for what kind of charge on the sodium? Positive. This one's negative, that's got to be positive. Well, if you look on your periodic table with the oxidation numbers, you'll find that sodium has only one kind of positive charge. If you don't have out your test references, you are preparing for failure. You should be looking on and working with me here. Okay? So we're going to put a plus charge on the sodium, and then we're going to find this. So we're going to introduce you now to another part of the test references. It's called the common ions list. Look at your test references and find common ions. Common ions. Wait, she says. Let me find it myself. You don't have to look up here. Okay. All you got to do is look for his name. Look for the name. Look for the name. Not SO3 negative, because that's sulfite. Okay, SO3 2 negative is sulfite. I'm looking for sulfate, which is SO4 2 negative.
How do we know the polyatomic ions?
What now?
How do we know the polyatomic ions?
Because I'm giving them to you. That's how you know.
So we'll have them
This is part of your test references. Okay? You have to look at the names to figure out if it's a polyatomic ion because it'll have an I or an 8 ending if it's one of the polyatomic anions. There are 2 exceptions. Some of the polyatomic cations, you just got to kind of figure it out. Okay? We already know about ammonium. Okay, that's a polyatomic cation. Okay? All right. So if I'm putting this together into a neutrally charged compound, how many of each ion do I need? 2 sodiums, she says. Does that make sense? If I have 2 sodiums, I'll have 2 1+ charges, and I'll have a 2 negative charge. And what's that going to equal? And that's what I want. That's a neutrally charged compound. So we're going to have 2 sodiums. And I need to have that coefficient 2 here to show that this is bonded with this sulfate ion. It has to be written as a subscript here. So sodium sulfate has this formula. Now there's something else we need to know about when I have a polyatomic ion in a formula. Actually, when I have more than one polyatomic ion in a formula. Let's take a look at another example here. We're going to put together a calcium ion and an iodite ion. Okay? So remember, if there's an ITE ending, it's a polyatomic ion. If there's an ATE ending, it's a polyatomic ion. Okay? So let's find calcium. First on the periodic table with oxidation numbers. That's a metal. 2+. Okay? And what about the iodite ion? ITE ending ions are going to show up on your common ions list. Subscript 2. But it's IO, right? Iodine and oxygen, subscript 2, negative charge. Now it's important to remember this number down here. That means I have a certain number of the element before it bonded together. Maybe bonded together with something else in that formula. What's up here in the upper right is a charge. That's a different thing, belonging in 2 different places. Okay? Well, to make a balanced compound, how many of each ion do I need? Not iodides. Iodites. I need 2 of these. Okay? Alright, let's put this together then. Anybody see the problem? You already figured it out. You were taught in physical science. If you didn't have physical science, or you don't remember from physical science, what's wrong with what I just wrote? That'd be like 20. If I had left a 2-2, there'd be 22 oxygens, wouldn't it? Well, Well, that'd be like 22. But we don't want to do that. What we want to do is to show there are 2 iodites, and you use a parentheses to show that. Okay? You only put the parentheses around the polyatomic ion itself. Okay? You have more than one polyatomic ion. And a formula. Put the polyatomic ion in parentheses. The number of ions goes outside that. And this is the only time that parentheses are used. In formulas. Yep. Actually, it's not the only time, but it's the only time we'll use it in here. Okay? There are some exceptions to this, but it's the only time we'll use it in here. Okay? All right. So, metals with only one oxidation number are named first, named like the element, and the polyatomic ions are named as they appear on that common ions list. Nope. Or if I do, I'll have to tell you what the name is. Okay, so you're going to have, on a test or homework, we're only going to be using these polyatomic ions. Okay? Other than when I might give you a name. I can't imagine doing that, but it's possible. Okay? All right, let's practice. Okay, you can work with a neighbor. In fact, I encourage you to work with a neighbor. And let's get these named, and then we'll have a chance to go over them and see how you did. So when we have a metal as part of a formula, an ionic compound formula that has more than one oxidation number, like manganese has 5 different potential numbers, we have to name each of them differently, and we use Roman numerals to do that. Roman numerals are like this. A capital I is 1, a capital II is 2, 3 I's is 3, 4 is IV, 5 is V, 6 is Vi. 7 is VII. 8 is VIII. 9 is IX. And 10 is X. This is how they number the Super Bowls. Okay? So manganese with a 7 plus charge is manganese 7 with no, the 7 goes into parentheses. The 7 goes in parentheses with no space. The 7 goes in parentheses with no space. And so the name of this one would be manganese 6. And I kind of left the space there. There shouldn't be any space there.
You have to write out manganese?
If you're saying the name of it. So manganese 4 is manganese IV. Okay? And so forth. So if I have a formula like this, I want to first look up the name of this part, and this is called iodite. Iodite has a 1 negative charge, and I've got 3 of them. I've only got 1 manganese. What charge will it have to have? In order for this thing to equal a 0 charge, positive 1. I got 3 negatively charged particles. If this is 3 negatively charged particles, then this will be 3 plus. 3 times 1 negative. So I have 1 of these. What charge has to go there? 3 positive. Okay? So the charge on this manganese is 3 positive. Therefore, what's the name? Manganese 3.
You were really thinking that. Yeah.
Okay, manganese 3 iodide.